All right, so now quick review. We talked about how to find horizontal asymptotes and vertical asymptotes for these general rational functions. The x and y intercepts are the same for any kind of function. Okay, for x-intercepts, remember that's an x value and y is 0. And so you plug in 0 for y. Okay, so I would be plugging 0 over here. Okay, for the y-intercept, it's a y value when x is 0. So you plug in 0 for x. In the case of these rational functions, a fraction is only 0 if the numerator is equal to 0, meaning you have 0 over some number that equals 0. Okay, and so remember, if you have 0 on bottom, that's undefined. Those are your domain restrictions. But if you have 0 on top, that's okay. That's the whole thing equals 0. And so those are your x-intercepts. Okay, and so in this case, 0 on top is your x-intercept. If you have a 0 on bottom, that's your vertical asymptote. Okay, and then as far as the y-intercepts, that's going to be really easy to find because if you plug in 0 for x, you're just killing all the x values, and what's left behind is your constants. And so let's start with finding the y-intercept. Okay, so for the y-intercept, we have 2 times 0 minus 4 on top. We have 0 plus 1 on bottom. That simplifies to negative 4 over 1, which is just negative 4. Don't say y equals negative 4 because that looks like a horizontal asymptote. You want to write it as an ordered pair. And so this would be 0 for the x, negative 4 for the y. And on my graph, there's the y-intercept. Okay, for the x-intercept, let's use red. That's where we set the top equal to 0. So that says 2x minus 4. Hopefully you can see that clearly on your copy. So 2x minus 4 equals 0. Add 4 to both sides and divide by 2. You end up with x equals 2. Do not write x equals 2 right here. Write it as an ordered pair. X is 2 when y is 0. So there's our point, our x-intercept right there. X and y intercepts are points. Ordered pairs. Asymptotes are equations. I'm going to write that as EQN, equations, because those are lines. Okay, and so we talked about how to find the vertical and horizontal asymptote on page 1. Vertical asymptote, you set the top equal to 0. Not the top, sorry, the bottom equal to 0. And so x equals negative 1 is our vertical asymptote. So at negative 1, I'm going to put a dotted line there. There's our vertical asymptote. Our horizontal asymptote, that's the ha funny acronym. And so let's use purple. And so in this case, we have a linear of degree 1 over a linear of degree 1. So they're the same, all the same. Divide the coefficients. So that would be 2 divided by 1. Y equals 2 is our horizontal asymptote. Okay, and so at y equals 2, we have our horizontal asymptote right here. Okay, and so we have enough information to graph part of our function. I'm going to use this. Okay, we know our function, and your vertical asymptote divides your graph into the different branches. So if you have one vertical asymptote, you're going to have 2 branches of your function. And so one of my branches is down here going through this green and red point, our intercepts, and it's going to follow the asymptote. So don't cross this vertical asymptote and don't cross this purple horizontal asymptote. So there's one of my branches. Okay, the other branch, it could be down here, but I know it's not because I don't have any more x-intercepts. If the branch was down here, I call the curve, this black curve, branches. If there was another x-intercept, I would know it was down here in this quadrant, but I know it has to be up here because I don't have another x-intercept. And so you can pick a point. You want to pick any point to the left of this vertical asymptote. So you could pick -2, you could pick -3. I'm going to pick -2 just because it's a smaller number to plug in. And you can plug it into the original function. So my original function on top has a 2x minus 4, and then an x plus 1 on bottom. And so we're testing, you could do -2, -3. I'm just going to do -2. 2 times -2 is -4, minus 4 is -8. -2 plus 1 is -1. So that becomes +8. And so now I can plot the point -2, +8. It's called point testing. Okay, -2, +8, and we will use green for that. So -2, +8 is up here. And so remember, you have to follow these asymptotes. Do not cross your asymptotes. Okay, and so this is what the function is looking like. As far as the domain goes, remember you have all real numbers except where this vertical asymptote is, which is -1. And so -infinity to -1, union -1 to infinity. Lazy notation, all real numbers except x can't equal -1. Okay, so that's how you graph. So for number 2, let's start with the y-intercept again. Okay, if I plug in 0 for x on top, I get 5 times 0, which is 0. If I plug in 0 on bottom, these two terms go away and leave me with a -8. Okay, so 0 divided by -8 is just 0. And so my y-intercept is 0, 0, meaning that's probably going to be my x-intercept as well. Okay, for the x-intercept, remember you set the top equal to 0. Okay, so the top is 5x, set that equal to 0. You get x equals 0. So anytime the origin is one of your intercepts, it's going to be both. Okay, so there's our x-intercept. For the horizontal asymptote, we use the funny acronym. We have a linear over a quadratic. So it's bigger on bottom. Remember, that's BOBO, y equals 0. Bigger on bottom, y equals 0. And so we actually have a horizontal asymptote right through the intercepts. And you'll learn more in pre-cal that you actually can cross horizontal asymptotes. We don't worry about that in Algebra 2, but I did want you to see an example that, hey, that does happen. That's why we're not going to be finding the range. For the vertical asymptotes, you never, ever, ever, ever cross a vertical asymptote. And so those domain restrictions are always going to match your vertical asymptotes. Okay, and so for the vertical asymptote, we need to set the bottom equal to 0, which is a quadratic. Got to factor that. Two numbers that multiply to -8, but add to -2. -4 and 2. And so x equals +4 and x equals -2, and put a comma, are our two vertical asymptotes. So I'm going to draw one at -2, and I'm going to draw the other at 4. Okay, so on this example, we don't have enough information to really graph anything, but I do know I'm going to have 3 branches. So I'm going to use a pencil. I could have a branch up here. I could have a branch down here. I'm not going to have both because this function still passes the vertical line test. So it's either one or the other. I'm also going to have a branch in here doing something. I'm also going to have a branch over here. Okay, and so we have to point test in each of these three sections. Your vertical asymptotes divide up your graph for you. Okay, so I'm going to have something over here, something in here, and something over here. And so the points I'm going to test is something to the left of this purple line or magenta line, whatever color, fuchsia. So I'm going to pick -3. Okay, so if I plug in -3 to this function, I get -15 on top, and then a 9 plus 6 minus 8 on bottom, which is -15 over 7. And all I really needed to know is that it's negative. It's a little bit bigger than, or a little bit smaller than -2. And so that's going to be down here. Okay, and so now that I have that point, I know that this graph, this branch is down here, not crossing the asymptotes. Okay, if I cross this purple asymptote, I would have another x-intercept. I don't, so this one actually follows the asymptote. Okay, over here, I need to test a point to the left and right of this x-intercept to know if it's making a cubic looking graph or a quadratic looking graph. We don't know unless we plug in points. So I'm going to have to plug in -1, and I'm going to have to plug in either +1, +2, anything before this vertical asymptote. So if I plug in -1, and I'm trying to do this in my head so this video isn't super long. So if I plug in -1, the 5 times -1 would give me -5 on top. And then on bottom, -1 squared is 1. And then minus, we have -2 times negative, which is +2, and -8, which would be -5 over -5, which is +1. So -1, 1. It's a nice point to graph. And then I'm also going to plug in +1 to this function. Okay, let me get another piece of paper. Okay, so if I plug in +1, we got to figure out the y value that goes with that. So on top, we have 5x over x squared. I'm going to show up the details for this one, just in case I've been confusing anybody. So 1 is going in for x in this original function. So here, here, and here. 5 times 1 is 5. 1 squared is 1. -2 minus 8, which is -1, -9 on bottom. So -5/9 would be down here, not quite -1. And so I know this is making an S shape in order to follow the asymptotes. Okay, up towards this asymptote because it's positive, down towards this asymptote. Okay, lastly, we need to plug in a point to the right. Okay, we've got 2 of our 3 branches. We need our 3rd branch over here. So since this is x equals 4, I'm going to plug in 5. Again, you could plug in 6, you could plug in 7, you can plug in anything over here. I'm just going to keep it as small as possible. So I'm plugging in x equals 5. And figuring out the y that goes with it. And so our original rule is 5x over x squared minus 2x minus 8. And this time we are plugging in 5. So on top, I get a 25. On bottom, I get 25 minus 10 minus 8. So 25 over 15 minus 8, which is 7. It's a little bit bigger than 3. So about 3.5. And so here at 5, we have 3 4/7. So 1, 2, 3, just plot it before the 4. And so it has to follow this asymptote and it has to follow this asymptote. So there's my 3 branches. These can look really weird when you're dealing with general rational functions. And so for our domain, we have to skip over the asymptotes. So we can go from -infinity to this, we have this branch over here to -2. We have the branch in between, so union with -2 to +4. And then the last branch, which goes from 4 to +infinity. A lazy way to say this, x cannot equal -2 or 4. All right, this looks wonderful. Last one. Okay, so let's start with the y-intercepts. I always think that's the easiest to start with. Kill all the x's. So there's -12 on top, -16 on bottom. The negatives cancel. Simplify, simplify, simplify. If you put 12/16 on a test, you're going to get that wrong. Those are both even, so I'm going to cut them in half. Still both even. The same as 3/4. You could also just do that right off the bat. Okay, so 0, 3/4, that's smaller than 1, so like right there. There's our y-intercept. For our x-intercept, it's an x value when y is 0. And so we have to set the top equal to 0. And so 3x squared minus 12 equals 0. There is a GCF of 3 that I'm going to factor out. And then that 3 is never going to equal 0, so you can pretty much divide both sides of the equation by 3 and ignore it. And so that leaves me with x squared minus 4 equals 0. Difference of squares. And so x equals -2 and x equals +2 are the 2 x-intercepts. Okay, so this is an example where we have 2 x-intercepts, which happens anytime you have a quadratic on top. Okay, and so I'm going to plot them both. One at -2, one at +2. So my 2 x-intercepts. Okay, for the horizontal asymptote, we're using purple. Remember ha, funny acronym. These are the same. We have quadratic over quadratic, so we divide the coefficients. 3 divided by 1 is 3. Okay, so y equals 3. 1 is right here for our horizontal asymptote. Vertical asymptote, we set the bottom equal to 0. We're going to end up with 2 because this factors to x plus 4x minus 4 as a difference of squares. And so x equals -4, and I'm just going to put a comma, and x equals +4. So those are our 2 vertical asymptotes. And so at -4, and +4. Okay, now that you have your vertical asymptotes, you can already go ahead and do your domain. We're going to have -infinity to -4, -4 to 4, then 4 to infinity, meaning x cannot equal -4, x cannot equal +4. I'm doing both notations just so you get used to both. And so we have 3 different branches. We have the branch over here, which we're going to have to point test to figure out what it's looking like. We have the branch here. We have the branch here. The middle branch, this -4 to 4, I can already see what it's doing because we have these intercepts here. We don't have to plug in points because we know those points are going to connect. And then it still has to follow this asymptote and not cross this vertical asymptote. not vertical, horizontal, sorry, this purple one. And so it's kind of looking like a quadratic in the middle. Here, it was going up. We only had that 1 point, so that didn't really give us enough information. Here I've got 3 points. And so I do have enough information to graph the middle branch. Okay, for the outer branches, it's either up here. It's probably going to be up here for both of them because I don't have any more x-intercepts down here. Okay, and so let's point test just for good measure. I'm going to plug in -5 because I want to be to the left to figure out the left branch. So I've got to be somewhere to the left of -4. So you could pick -5, -6, -10, whatever you want. And then I'm also going to pick +5 so I can figure out which point is happening over here. So looking at our rule, we have 3x² minus 12 over x² minus 16 in both cases, obviously. Okay, so since we're squaring this -5, it's going to be +25 in both cases. So we're going to get the exact same. This is going to be a very symmetrical function. So 75 minus, I'm going to cheat and use my calculator. 75 minus 12 over -16, not -16, 25 minus 16. 63 over 9, which is 7. So in both cases, we get 7 as our y value. So -5, 7, +5, 7. And so I know this graph looks like this. Okay, and so when you're dealing with general rational functions, you can have some really weird looking graphs. And so just remember that if you have one vertical asymptote, it splits it into 2 branches as shown by the domain. If you have 2 vertical asymptotes, it splits into 3 branches. And if you have, 2 vertical asymptote, 3 branches. Sometimes you have enough information to go ahead and graph one of your branches. So here we had 2 points. We had enough to be able to graph this. Here we had 3 points. We could graph this. But we had to point test for these 2 branches. We had to point test a lot in this second example because we didn't have enough information in any of them. And so the main things you want to remember is how to find these key attributes. If you're trying to find the vertical asymptote, set the bottom equal to 0. If you're trying to find the x-intercept, set the top equal to 0. For the y-intercept, you plug in 0 for x. For the horizontal asymptote, the ha-ha, you use the funny acronym. Okay, your asymptotes are equations. Your intercepts are points. Your domain always matches your vertical asymptote. You skip over the vertical asymptotes every time. You will never cross a vertical asymptote. You have some weird situations where you may cross a horizontal asymptote, but that's very rare and we don't worry about that in Algebra 2.